Hello? 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 I am audible now. Let me check if. Hello? I am audible now. Let me check if. Hello? I am audible now. Let me check if.
Hello,
I
how are you?
am good. How about you?
I'm good.
Yeah,
Yes.
you are done with doing
Yes,
work.
I'm done.
Okay, no problem. You are you able to see the screen?
No, I'm not. Yes, I am. No problem.
Okay, let's do. Where is it? Where is it? You said what do you want us to focus on?
Vertical projectile.
Vertical projectile. Okay, let me scroll to it. Yeah, here it is. Yeah, that's here. Yeah, here is vertical projectile. Is there a specific section of vertical projectile you want us to look at?
Yeah, I cannot say because like I think I thought of like written into vertical projectile. Yo, because you will never know or what they feel. And there's somehow is it a that is a sort
Okay,
like
okay, we can do all the vertical projectile problems. So we are starting with the very first one.
mm,
Okay, may you read the information for us?
okay, is question one. A ball A is thrown vertically upwards from a height h with a speed of 15 meters per second at the same instant. A second identical ball B is dropped from the same height as ball A, as shown in the diagram below. Both balls undergo free fall and eventually hit the ground.
Okay, this is the information that we are told here about the balls. So the first thing is there are two balls A and balls B. The first one
Mm.
was thrown up from the top of the building, and then at the same instant, a second ball B is dropped at the same height, and ball A, as shown below, both balls undergo free fall and eventually hit the ground. Okay,
Mm.
so we are told that all of this motion started at the same time. So that's the something that you have to note. There's not that thing of saying that another one was thrown a second later or 3 seconds later. So what do you understand about free fall?
Free fall is a motion during which the only force acting on an object is the gravitational force.
Yes, that's right. What is projectile?
Projectile is an object which has been given an initial velocity and then it moves under the influence of the gravitational force only.
Yes, that's also right. So, a free fall is a motion, and a vertical projectile is the focus on that object. So now let's go to the question itself. It says that calculate the time it takes for ball A to return to its starting point. So ball A is the one that is thrown upwards. It comes back to its it comes past its start point and goes down directly down. So now they want us to know the time it takes to go up and to go down. So we must first name our variables. V initial, what's the first choose direction up as positive, ne?
Yes, upward is positive.
And then so what is initial velocity?
The initial velocity is 15 meters per second.
Okay, you can choose whether to write positive or not, but it just signifies it's upwards. And then what will be the velocity when it returns back to the same height?
0.
When it comes, let's take it for example, ne? You are
Mm,
you are standing on top of the building. You
yes.
throw something upwards, and then it comes back. So what will be the velocity the moment when it is passing at the same level that you throw it?
I think it will go with the same velocity which I've thrown it.
Yes, that's very much true.
Negative
S-
15.
So it's going to be negative 15.
Yes.
So what you have to note is that the velocity that you throw it
Mm,
and the velocity that it comes back to the original location is the same.
the
Just like
same.
if I'm
Okay.
holding a ball on a hand, the velocity that it throw it upwards and the velocity that it comes up back with is the same. So even if the ball is bouncing, the velocity that it leaves the ground with, it will be the velocity that it comes back to the
Come
ground
back
with.
to the.
So it's
Okay.
just like a curve. So another thing that you have to know if something is coming back to its original position, because the second question tells us that it returns to the very same position.
Hi.
You must know that.
Mandi
mm,
class ini, hi. You can continue.
Okay, the second thing that you must know is that what will be the displacement if it goes back and comes back at the same height?
It will be 0.
Yes, that's what you have to note because displacement equals to final position minus initial
And this
position.
initial position. Yes.
So what other variable that you know?
Acceleration.
Gravitational
Negative. Yes.
acceleration, meters per second squared. So there it is. I think that's all we can find. So they're asking for the calculate the distance, or they say calculate the time it takes for ball to return to each starting point. So which formula has time? The one which is maybe simple and straightforward?
Equation which says V final is equal to V initial plus A delta T.
Yes. So now let's substitute here. So
Negative 15. Yes. The answer is 3,06.
the answer is what?
3,06 seconds.
3,06 seconds. Yeah, that's our
Yes.
answer there. So let me just write it here so that I can wrap there. Let me wrap here. So, and then calculate the distance between A and B when ball A reaches its maximum height. So, this one is gonna be very interesting. So, because they want the difference between the distance of the balls, while list they are both still in motion, but we are given the exact point of one ball, but we just don't know where the other ball is. So it
Mm.
tells us that when ball A is at maximum height,
She's
they wanna
maximum.
know where ball B will be, and then we get the position or the position of B. We'll take the position of A because A will be on top, and then we'll
Mm.
just say minus a position of B, and then we'll get our distance. So, which means
Okay.
that the first thing that we have to do, we find the maximum height of the first ball. The second thing that we
Distance.
do, we get the
The
distance
distance
or the
of
displacement
the
of ball A at that exact time. It means that maybe we can first find the time it takes for ball A to reach that
to reach
maximum
the
height,
maximum height. Okay.
because it is the time in which B will have traveled. And then we check that, or in that specific amount of time, where will B be? For example, if you left the house at the same time, so when that one reached his maximum height, where will you be at that same time? So we have to use A to find everything. So let's see what A can give us. So we got the time it takes for it to return. So at physics, you must always check whether the question on top is related to the question on the bottom. So do you see any relation to the questions of 1.2 and 1.3?
1.2 and 1.3. Um, I don't think that they are much related because 1.3 is talking about when A reaches maximum height, whereas 1.2 is talking about like mm, it's a different story though.
Okay, it's a little different story, but it's not completely different. Okay, let's say, what do you know about the distance of going to the maximum height and coming back to the same distance? What do you know about that?
Um, One thing I know is that when an object reaches maximum height, the final velocity over there it is zero to the
Yes.
maximum height. It's supposed to be zero, and then about the time is supposed to be the same. Like when it goes to the maximum height and returns back, I think it won't change.
Okay, you are right. What do you know about the distance of going up and the distance of going down? Okay, let me just say, what do you know about the time of going up and the time of going down?
It's equal.
It's equal, meaning you can get the time of going up or going down by doing what to the total time?
I
If if
I
in
don't get it.
Okay, you just said they are equal, ne? Let's keep that.
Mm.
So if they are equal, it means that you just have to divide this time by 2 in order to get the time of going up and the time of going
And the
down.
time of going down.
Yes, because a 2, this represents 2 a time, the time of going up and the time of going down. It's
Is
represented
equal
by
to
what?
3.06.
By this, and we divide it by 2, and then our time is gonna be how much?
Yeah, I'm lost. Okay, divide by 2.
1,53.
One comma 53.
So are you still lost?
No, I was
Yeah.
still reading the question. Okay, it was like calculate the time it takes. The time it takes for ball A to return to each starting point.
Yes. So
Oh,
they needed you to also use this time, because this time will
oh, the
be
time. This time is like the time of the motion of A, the whole motion of A when it
uh,
goes somewhere and returns back.
so yeah, the three seconds is the time for whole motion of a from the
Mm.
top of the building back to the level of the top of the building.
Okay, I now I get it. Or why divide ang two.
Yes.
Sharp.
So it would have been a long way if we first try to find the maximum height and everything, while this we can just divide it by 2. Ne?
Mm,
S-
mm.
So this time is very much important because it is the time that ball A will have moved and is the time that ball B would have moved. So we are using this time to calculate the distance where these balls will be at that certain time.
All right.
Okay, so let's look at the formulas now. Let's look at the formulas and see which formula can we use to get the distance. So we are looking for formulas that
I think
have the distance.
I think we can use delta y is equal to final velocity minus initial velocity all divided by 2 multiplied by time.
Final velocity minus initial
Initial
velocity
velocity all
all
divided by
divided by
2.
time. Okay.
No, all divided by 2 multiplied by time.
Okay. Yeah. Thank you. Okay. All divided by 2 multiplied by time. Ne?
Yes. Yes.
So we are using which one? We are using in ball what?
Ball A first.
Yeah, let's do ball A. And then what is final velocity?
0.
Initial.
15.
And then minus 2 or over 2. And then what's the time?
The time is 1,53.
1,53. And then how much does it give us?
Wait. Wait. 1,53. I get your negative 11,48.
Negative 11,48. Why is it negative now? Let me
Did
see.
we choose the direction?
Let me see if it is necessary. This one is going up. So, oh, yeah, it is right. This one is going up because you see the
Initial
initial
velocity,
velocity
yes, is going
is
up.
positive. So this
Yeah,
negative
with
is
this
from the sign.
direction.
And then negative just means downwards. The
11,
distance is covered going downwards. So there it is. And then we go to the distance of B.
of B.
What do we know about B? Let's list the variables that we know about B. Initial
We know the
velocity
initial velocity, which is 15.
is 15.
Your ndivyo ziva.
It's zero because
Yes,
it
it's
was
not 15,
dropped.
it's 0.
Yes,
It
it
was
was dropped.
dropped.
What else do we know about B?
Acceleration and also time.
Acceleration negative
Mm-hmm.
9.8 meters per second. The time, what's the time?
1,53.
Yes, that's the very important part. So, with all this, which formula can we use to get the distance?
Let me look first. We have the velocity, acceleration. We can use V final is equal, VF squared is equal to VI squared plus 2A delta Y.
Okay, no problem. I see, I think someone has joined the
Oh, yeah, I
call.
invited some friends.
Oh, okay, no problem.
Mm.
Feel free to ask questions if you do have any questions. So, we are using this equation,
Yes.
V initial a change in time it's plus half a change in time squared. We just substitute 0 into change in time
1,53.
plus half into negative 9.8 and then the change in time squared.
Mm.
Okay, so press on the calculator.
Um. Okay. Wait. 1,30 over 2 into. It's negative 9,8, right?
You got negative 9.8.
No, I mean, okay, I got
Oh,
negative 11,47.
negative 11,47. Oh, sorry, 47.
47.
So, meters. So, this is the distance in which ball are we talking about here?
Ball
Here,
B.
here we are talking about ball B. A ball B. So it's gonna just be 11.47 meter downwards,
Yes.
and then this one is also downwards. But there's also another important thing that
Mm,
you have to note.
yes.
Um, let me check the displacement of this ball. Let me check on the displacement of this ball. So the ball A is gonna first go up, and then it comes back and goes down, and then there's also gonna be a ball B. So what you have to note is that this negative here,
Mm,
this negative of ball A, if you check ball A,
mm.
when does it starts to have displacement? I think that's something which is very much important. When does this ball start to have displacement?
Um, immediately after it leaves the maximum height.
Okay, wait. Here we calculated the distance of which ball?
We calculated the distance of ball A over there. Then,
Or when it is above here. So this is the distance of ball A from here to here, and then
mm.
will be the distance of here from here to here. So now this
Mara, I have a question. Like when ball A, when it's going upwards to the maximum height, like the distance is supposed to be negative, like negative. Or Mara A,
no,
negative because of the initial velocity. Mm.
it's supposed to be positive. That's also something that I'm also looking at now. Uri, why is it negative? But when you check the V final that let's check all the variables that we have put. V final is this one,
0.
and also this one is this one.
We took upwards is positive, right?
Yes, upwards is
So
positive.
yeah, it's supposed to be minus 15 over them.
Minus 15. Okay, so the time and everything. So are you sure you press the calculator right? Or the formula you are sure it's like this, ne?
Yeah, the formula I'm very much confident is like that.
Okay, let me just press
We
the
can even try using another formula. It is alright. Let me try to calculate again. Maybe I made a mistake.
you didn't make a mistake. You didn't make a mistake.
Yeah, it's correct.
So the time is gonna be okay. Let me just recheck the formula, uh, and then we'll see what we can do. Okay, let me just use this one of saying vf squared equals to v initial squared plus a change in y, and then I just substitute here. The final is gonna be
0,
or 0. The initial is gonna be 15,
15.
and then plus negative 9.8, and then there is our y. and then our y is gonna be this one. We put it this side is gonna be negative 15 squared over negative 9.8. Change in y, how much does it give us?
Over negative 9 point. Is the negative sign outside of 15 or is supposed to be inside or outside?
It's it's
Sharp.
it's it's
I got
outside.
I got 22.95.
You get 22.95. Okay, so you got 22.95. Why is it different from this one?
It's different because over there we included time, like we included the time which is 1,53. Like
Oh, wait. Here we are solving for the distance.
yes.
V final squared plus this one 1,53, the time, and then this this formula got 22.95.
I will go with 22.95 because yo
Okay.
like A in a include that time it they're similar like I
They're similar, so if
they're way too similar. Let's just try to do that one first. Like the other one, yeah, behind your A. Let's consider it as distance here. I wanna have my A 22.95. Then let's try to look for B. Marara song will include the time.
okay, let me let me confirm with the calculator, and then I will continue now. We'll,
Okay.
we'll continue. Let me just confirm, and then 22.95. So this one is gonna come here, and it's gonna be, let me just do it manually. So the square root of 15 squared is gonna be 225 minus 9.8, and then y equals to 0, and then this is gonna come this side. Yeah, it's still gonna give us the same thing. It's still gonna give us
Hmm.
the same thing. So okay, let me look at the scenario. It says that there is 15, there is the change in y. I also trust this one, but even okay, let me check the formula sheet, and then I'll tell you where to go from there. Do you have the formula sheet with you there? Do you have any question paper?
No, I don't have any question paper. I only have the question papers for Nonisha.
Please check the formula sheet. Please confirm the formula sheet.
Okay, about the equation.
Yes, about this one.
Which one?
Oh, in this equation, there is
There is acceleration. Oh yeah, we did include acceleration. Yeah, there's two.
there's 2 in this
And then
equation.
Ah,
Okay, just press like this. You know,
two
ceiling.
into negative. You guys. Okay, wait.
So
I got 11,48 again or 47 if this one we run off.
yes, yes. So it's the same thing, but this one is positive.
Yeah,
Meaning,
this one is positive.
yes, this
What?
one is positive. Meaning this one here maybe the sign here. Okay,
Yeah, the equation like yo. No wonder we
okay,
were trying to say consider.
Okay, are you finding the question paper there?
Yes.
What does the question paper say
The question paper about the formulas.
about
The
this
formulas?
formula?
Which one?
This one.
Yeah, that is the true formula.
Okay, this is the true formula. This formula is for finding the average, uh, distance, if I'm not mistaken. So, but because the other one gave us a positive answer, I think we can just stick with the same number, but take it as positive because this one gave us a positive answer. And then
So
now,
it's going to be 11,48 minus 11,47.
they say the distance between them. So this distance going up is 11,48. The distance going down is 11,47.
Okay,
So
minus
no,
7.
the distance between them. So we are adding. They're
Yeah.
starting
Oh,
at the same
between
time.
them.
Yes.
Yo. I got 22,95.
22,95 meters. Okay, there it is. Okay, we'll confirm at the end.
Yeah, can we please read the question again? Again.
So, okay. So it says calculate the distance between ball A and ball B when ball A is at its
It's
maximum
at
height.
the maximum height. Okay, the distance between ball A and ball B when A is at the maximum height. And then at first you said that okay, car 1.2, the time which we calculated in the about 3,06, like initially is a time which like was there commotion your table A, like yeah, that is the time which ball A covered.
Yes, from
And then we divided it by 2 because
yes.
yeah. Okay. Clever. Okay.
Do you have any questions?
Nope.
So, okay, let me just write down this answer here. We'll verify it when we are done. 0.95 meters. Okay, but I think we are gonna use some of this information to draw the graph. Let me just keep it here. Sketch the velocity time graph on the answer book of the motion of ball A from the time it was projected until it hits the ground. Clearly show the following on your graph. You must show the initial velocity.
Yeah, that's the problem. Drawing the graph.
Okay, so they say of a. I'll try to teach you drawing ball A. So we are considering the motion of ball A, the time it takes to reach the maximum height and the time it takes to return to its initial position. So let's just have a velocity time graph like this maybe. Then we must name our graph. Direction up is positive. So, and then this side will be velocity. This side will be time.
Time.
And then the velocity, because ball A when it starts is projected upwards like this, then it comes down. So they need this initial velocity, which is plus 15
15.
meters per second. And then they say what the time of the maximum height, ne? So they need the time here, which is 1,53 seconds. They need what when it returns to its maximum height. They need the time when it returns to its original position. So its original position, the time here, which is 3,06 seconds. So this is here is 0 seconds, and here the velocity is 0. Pela it's like I'm plotting now. If you don't want to, if you wanna plot, you can plot. Just have to find the right information. This is velocity will be negative 15 meters per second. They don't want the velocity when it reaches the ground, so we don't have to care. So let's say we are this side, we are counting in 5, 10, 15, 5 or 10, 15. This side negative. Oh, here's gonna be 0, man. Let me put my 0 there. Let me put my 0. There is my 0. 5, 10, 15. 5, 10, and also 15. So now what I have to know is that the ball starts here at 0 seconds. Let me just count with 1,5, because that's what we have.
5.
1,5, and then we have 3, and then we have 4,5. Oh, is it correct? Yeah, I think it is. Then we'll have 6, and then like we just plot. We have a point here at 0 and 15, and then the next point is, let me use a different color. The next point is this is our first point, and then the next point is 0 of velocity and 1.53 of time. So it's just in front here, and then the second,
So like, okay, that's how you plot it. Like, yo, guys, okay.
yes, you can plot it like this. And then the other time that we have is 3 seconds and
Yes.
negative
Negative
15.
15.
So these are going to be negative, and
Negative,
then
negative.
now this is 3
3,06.
and 3 and here, so it's just in front of 3, and then the last time that is there, but they didn't say we must show it. It is just the time it will hit the ground with, so it's somewhere up here, so it means we must just extend the graph until the velocity it will hit the ground. So this is our graph. This is our graph. Just yeah, and then this is the time they say we must show, and then yeah, this is it. But here you must just write, or I don't know if they by show, I think they mean you just come and do this and say 3,06, and then you just come and do the and say negative 15 meters per second, and then by the other show that they said we must show is initial velocity, you just come and say 15 meters
15
per second.
meters per second.
Yeah, I think yeah, this is the 0. This is the time they said you must show, 1,53 seconds. So that's how you draw the graph.
Yeah, Mara, I think velocity versus time graph ya sorti iva ichikomba like iva ichikomba ka acceleration, because we Regia upwards is positive and then our graph is going down. Osmeasure acceleration never meaning in negative. But if Regia downwards is positive, I think the graph was going to face upward to show
Yes.
that the acceleration is positive. Am I right?
If we took downwards as positive, the graph was going to be something like this, and then this will be your starting
Negative
position,
15.
-15. This will be your 0, and then this will be your +15 when it reaches the same level, and then this is gonna be until it hits the ground.
Okay.
Yes. So you must note what they said. You must indicate, and then yeah, ngoraro ngoraro. Let me.
We are good.
Okay, if you don't have any questions, let me see if I can get to the memo to just verify. think it's down here. Where is it? Yeah.
Next question.
Okay. Oh, is okay. Yeah. I think we must. I'm saying let's first verify. Ne? Okay. I think these are the two, and then this one also. Copy, and then just go up there. I think yeah, this is it. Just put it here. Paste. So these are what the memo is saying. These are the answers. 3,06. We got it. And then the second one, they got 11 and 11. They added. We got it. And then this one, we also got it. Do you have any questions? Hello, are you still there? Is anyone still there? Faith?
Yeah, I'm still listening. I don't think she's still available.
Do you have any questions though?
I have questions because I just got here and I don't know where everything is going. I'll take it from here. Then if I have questions, I'll ask.
Okay, yeah. In this next one, because we are starting from a new question, it means that yeah, you'll have the context.
What did I miss? My network was gone.
Oh, we just verified it, and the answers were the same.
Muna memorandum.
Yes, the document has compiled questions and compiled memo.
Which document is this? Do I have it?
Terms and definitions. I think I once sent you a long time ago.
A long time ago.
Yes,
Message
when
you, okay.
at the beginning of the year when we started having classes.
Yeah.
Okay, I'll send the document to you. Give me 2 minutes. I'm coming back now.
Mngana we. Nakalo.
Makwarera.
Ukuzwifaiwe.
Because if I just did not take out it's so
Your network ingangari zvino.
Wait, I'm going in 2 minutes, my friend.
Wambona.
Your faith can't be seen due to network what?
Ay. Aha. Way. Shame. You're going through a lot. Mngana we live was you were live so. No.
Okay, so we can
Can I
continue.
ask?
Yes, you can ask.
Live.
Yes, you are.
Okay.
You are. You are. On
Okay.
so on YouTube though.
Oh.
Yes. So we can go to the following question.
Yeah, we can.
So did you share the link with the rest of the classmates?
Yes, I did.
Okay. So you can read the question.
Okay, the question 2.
Oh, we are in question 2 now, ne? Oh,
Yes.
yeah, it is so little. That's why I missed it.
It says an object is released from rest from point from point X above the ground as shown in the diagram. It travels the last 30 meters BC in 1.5 seconds before hitting the ground. Ignore the effects of air friction.
So
Yes.
we are told here that an object is released from a point X above the ground, and is shown in this diagram, and travels 30 meters BC, that is, in 1.5 seconds before hitting the ground. Ignore the effects of air friction. So, okay, we are told the distance it moves past that point of 30 meters. It is released from rest at X. So yeah, I was just trying to understand that. So now it says that name the type of motion of the described above there.
A vertical projectile.
Uh, what is vertical projectile describes what?
Yo. A vertical projectile describes when an object which has been given an initial velocity and then it moves under the influence of the gravitational force only.
Yes. Vertical projectile is about the object, but
Mm.
which one describes the motion?
It's free fall.
Yes, free fall is the one that describes the motion. So the type of motion, it's free fall. So you must note that some people even describe vertical projectile to say that an object that has been given initial velocity and moves under free fall. Ne?
Mm.
Yes, because it is a object that undergoes free fall, the motion in which the only force that is acting on that object is gravitational force only. And then they say that calculate the magnitude of the velocity of ball of object at point B. So let's check the information. So before even me, I don't have a idea already which equation and what formula are we gonna use to calculate this. But the first thing and most important thing is to list your
Write
variables.
down the emotion. Mm.
Yes, write down choose direction up, maybe as
Oh,
positive. I think that's the only one that is that's the one that's easy. And then you choose what's the initial velocity.
0.
It's 0. And then what else do you know about this? Let's
Um,
say
it
uh,
travels the last 30 meters.
calculate the magnitude of the velocity of the object at point B. Ne?
Mm.
And then another thing that we can also use, we can also know from, okay, we need the velocity at point B. Ne?
Yeah.
So
We also have what's the acceleration.
yes, but this is
Mm.
initial velocity at X. Ne? And then
Yes.
this one is gonna be 9,8
Negative 9,8.
meters per second. Yes. And then another thing that we also are given by the information.
It travels the last 30 meters BC in it's 1.5 seconds like
It's between this segment. This is from X to B. So it's from this segment. So there's also segment maybe B to C that we are given its variables. The section B to this, the one that says it takes 1,5 the time, ne? Second, and then we are also given its distance. Change in y
it's 30
equals to
meters.
30. And then yeah, there's that. But we don't know the
Final velocity.
the final velocity and the rest, and the initial velocity is the one that we are looking for, ne?
Mm.
Okay, let me just write here. Let me just write that. Let me just write. Oh, this is A, ne? Why did I write 9 this side? 9,8. Negative 9,8 meters per second squared. Yes, so now which formula can we use? It's either we use these ones going back to this point, going back to this point, or we either
Yes.
use this section going back. Which information, where do we have more information to use an equation, here or this side?
BC.
It's on BC. Which equation can we use on BC?
I'm still looking. Okay, BC is going to be the initial velocity. It's not gonna be the final. So
Yes,
we can use, huh?
yes.
Am I right? Yes, we can use delta y is equal to V initial delta t plus 1 over 2 a delta t squared.
There it is. And then we come and substitute. So the distance, we must,
It's
if up is positive, distance is covered going down, which is negative.
negative.
And another thing, let's just substitute it as this, and then the velocity we are looking for it. This time we are given 1.5 plus half into negative 9.8 change in time. So the important thing that you had to know here is just that you just had to work backwards. Just have to work backwards to get your answer there. How much do you get there?
I'm still calculating.
You just took the other one that side.
Okay. I got a negative 19,18.
You got negative 19,18 meters per second. And then what will your negative mean?
Downwards is going downwards.
Yes, your negative will mean that it's going downwards.
Yo. Right now we're speaking a different story. I'm gonna kak.
How much did you get?
Yeah, right now I'm getting negative
12,6.
12,65.
Okay. Meters per second. And then, so, yeah, there is our answer. So, do you understand?
Let's speak again. What do you mean?
Okay, so here you just had to know that you can either work from the initial speed going down, or work from this section, the last section of motion. So the most important thing at physics is to identify the section of motion that have enough variables to work with. That's why I first listed this, and I realized that 2 variables are insufficient in those equations of motion to solve one. So, but 3, they are sufficient. The moment you know maybe 3 things, it's sufficient for you to substitute. So, and then I found out that I'm given more information towards BC. Therefore, I will make, instead of making B the final velocity or the final position, I will make B the initial.
Okay.
Okay. So, do you all understand?
Yes, I do.
Okay, so let's just write it here. 12.65. It is positive, but negative just means downwards. So that, yeah, when we wrap, we don't wrap the answers we might be using as time goes. So let me wrap here. So this next one says calculate the height of point X above the ground. So this is the point in which it was dropped. So
Yes.
they want you to know the height in which that ball was dropped. First, you have to first know again which section of motion are we gonna use. So if we come here at X and B, we have the V final of X and B now, which is
Yes,
what?
which is 12,6.
12.65 is. And then they say calculate the magnitude of X. So now, because you have the V final and you have three known variables, which equation can we use to which also has distance to solve for this distance? It will solve the distance from here to here, note that, and then the distance that will be solved between X and B, because the variables are giving us the distance of X and B. The distance that we'll get, will add it to 30, and then we'll get the height of X above the ground.
Okay, we can use the equation which says VF squared
Vf squared equals to V initial
to
squared.
VI squared plus 2A delta Y.
Yes, so now let's just substitute.
Hi.
And then we just solve this.
It's squared. The negative 12.65 it is squared.
Thank you very much. I would have missed that. So there's nothing here. Wait. No. The negative, multiply the negative there. Oh, yo. What am I doing? This is a race. Wait. Yeah. Let me just do this. Into negative 9.8.
Negative 8,16.
8.16. Okay. So is it negative or positive?
Negative.
Okay, it means it's covered going downwards. Okay. Does it make sense according to the information? Yes,
It does.
X is going downward. So another way to verify your answer is this way, to say that does it make sense according to this without working again. So now another information is to say that because we get this distance from here to here, which is 8.16, we have to add it with this one. 30 plus 8.16 will give us the height of X above the ground.
Is 38,16.
Equals to 38.16. And then we just come and put it here, 38.16 meters. So do you understand? Do all of you understand?
Nendiko pesos. Or
Would
you
it-
not?
Okay.
I feel would be daki.
I thought I saw huria fala kana mara ungoropi huri kana oshumisa ntu ya mwe.
No,
Design.
it's because of blessing that done with email so that's what you want to
Okay. and then sketch the acceleration time graph for the entire motion. Acceleration time graph. So let's just rub here. Or let me rub here at the beginning,
Yes.
at the bottom. So this is the ball that it drops. It drops, and then when it drops, it's going to hit the ground. So they say that it goes through point B there. It goes through point B, C, B, and then it goes to point B. So it says that after hitting the ground, the ball bounces once and then comes to rest at the ground. So okay, there's a bounce. I missed important information to write an acceleration time graph. So there's a bounce there. So acceleration time graph is a simple but also complicated acceleration. But I would prefer to draw velocity, and velocity is the one that I think it's straightforward.
Mm.
So we are going to choose upwards is positive. So upwards is positive. So
Take
in
it, I'm mute too.
okay, yes, thank you. In upwards is positive, so it means acceleration is negative the whole time. So it's gonna be negative
Negative
9.8.
9.8.
Negative 9.8 in a straight line until it reaches the bounds. So at the bounds, there's something that really happens, because
Like something like asymptote, so
something like asymptote.
like
But
dotted lines.
yes, dotted lines. Yes,
Understand?
I was confused when you said asymptote. I thought maybe there would be like I mean, there would be like a concept of maths or something, but you just mean dotted line. So, and then it goes to a point where it's -9, it comes back, it's +9, and then it comes back. So, but other textbooks make it up until 0 and then it comes back. But just know that that milliseconds of a bounce, that's like how the graph will shift towards the 0, and then it comes back, and then it continues at the same. So when I tried researching, if I remember well, why I researched in grade 12 why it does this, I think I got something like that there are other forces included. For example, there's because free fall is when the only
There's
force.
what?
I haven't said the force. Free fall is like when there's only gravitational force acting. But now when it hits the ground, there's gonna be an impulse, the force of the ground on the ball, and also some friction, and all those kind of things that shifts the acceleration upwards, or shifts the acceleration of the ball to be redirected upwards, because the force that the ground will exert to the ball will be towards upwards. But up until the ball is no longer in contact there, it's gonna be only gravitational force that will be acting.
Alright,
You
I
don't need to
understand.
understand all those because they don't ask it, but it's just for you to know that this section of the bounce, that's when it's no longer negative. Or if like you were
Experiencing the gravitational force only.
except, but if they had said positive, it was going to be like this. If they say up is positive, continue like this. So there it is there. And then, do you have any questions?
I don't, Shem.
Okay,
Mario.
let's check the memo if it's here. Is it here? Yeah, it's here. So there is the memo. The answers we got them. The graph, this graph, it put it at
Iterate.
0. Yeah,
Yeah.
but I don't think they will mark you wrong, because other textbooks they put it at the opposite -9, but here they put it at 0.
Okay.
So, okay. So, which is there anything else that you want us to do? Maybe this in the same topic or in another topic.
Now let's do. Okay, in this topic, vertical projector whatsoever. The difficult part in Amanati, it was the graphs, guys. The graphs are way hectic and other stuff, but then, because one at so we cannot focus car vertical projectile base. So I need us to move car electricity, those charges whatsoever. It's
You mean
total.
electrostatics?
I mean, electrostatics.
These ones.
Mm.
Which one do you want us to do?
Yes. As momentum, no, I'm talking about the
Is
charges.
I think, oh, this is momentum. Ne? Oh, it just looks similar. There's something like that in the momentum. So yeah, yes, it is electrostatics.
Sure.
Which one do you want us to do?
The first one, question 1.
Okay. So may you read the
Okay.
information?
I cannot see.
Oh, sorry. Okay, you can read.
Okay, it says the diagram shows two small identical metal spheres, R and S. Each placed on the wooden stand. Sphere R and S carry charges of +8. Is it Coulomb? And -4 whatsoever Coulomb. Representatively, ignore the effect of a.
Okay, so it's microcoulomb. It's microcoulomb. So
Okay, microcoulomb, the one which is MC NDP.
the one that is, what do you mean MC?
Like yung small letter M nako C.
Small letter M. I think it's macro or something. There's micro and macro. So
Yeah, it's Marco.
it's macro, ne?
Sure.
Yes. Okay, yeah, it's macro. The one that is M is milli. There's milli. Let me show you the table. There's a table that I can show here.
Wait.
There is like, let me just show it. There's someone wants them to help their little brother in grade 11 with electrostatics. So I'm thinking, or because I think these things are similar, grade 12 and grade 11, maybe I can just tell them to join the link now because we're doing electrostatics.
Yes.
Because I think they are similar. Let me just show you this graph. Let me show you this graph. Where is it? This one. This is the graph.
Milli.
You need to know it because when we start doing calculations, you have
I
to
do know where
substitute.
if you in the ikera negative bongana, those ones I do know. Mara mazina ao neti.
Okay.
Film chokulo mwitwanga warini. Hi.
Or what did you say?
The femto. Do we do it? No.
You might do it, but like, you might do it, but they usually don't bring it.
Sure.
Yeah, -12 and -15 barely counts.
Yes, they barely come, but you just have to know it because this examination are full of surprises. They might bring where you don't know the micro milli, and it means that you are wronging everything. You are
Yo,
you,
can you please I wanna sharp. Yeah, you can move.
okay. So wait, okay. I have this one. You can read the first the scenario, or you can go to the first question.
Okay. The question is says explain why the spheres were placed on wooden stands.
So why do you think they were placed on wooden stand?
Mm. Mm-mm.
So what do you know about charge? Charge is like something which is it can be lost. So wooden base is like acts as an insulator, so that charge is not lost. So is so that charge may not be lost.
So like okay, so the charges may not be lost.
So that charges may not be lost.
Okay.
And then when it continues, yeah, I think he joined. Let me check if it is him. Hello, Rachel.
Oh mute.
Are you able to hear me? Because I cannot hear you.
You're muted.
Let's hope. Just know that I cannot hear you. But I hope you are hearing me though. So, okay, we were doing this one of saying that why do we put charges in the wooden base? Is that in the wooden base so that they don't lose charges. So you must keep that in mind to say that that's why if it was a conductor, charges if it will be lost maybe to the other substance. For example, if it is a metal table or something, and then you can continue reading.
1.2 sphere R and S brought into contact for a while and then separate by a small distance. 1.2 calculate the net charge on each of the spheres.
Okay, calculate the net charges. So charges are contact and they are released. What's the formula that we can use to calculate the charges that have been contact for a while and then they are released? In the meantime,
Um
let me try be getting the formula sheet. Okay, which one? Which formula do we use?
yeah, I don't know, Sham.
So
I really don't know a lot about electrostatic.
okay, it is we use that formula in which if two charges are brought close together for a little while, we use the formula in which we combine the charges of the two spheres and we divide them by two. Do you remember that
Oh,
formula?
Q nu is
Yes,
equal to Q1 plus Q2 all over 2.
yes, that
Because
form.
we are setting a new charge, Q new.
Yes, we are gonna have a new charge on each of the spheres when we solve. So we are gonna do it like this to say Q new, or you can say you can just say Q equals to Q R plus QS over
Yes.
2, and then yeah, you just come and say 8, and then you must know that what does a micro stand for. You must know that micro stand for 8 times 10 to
Times
the power
10
negative
to the
6.
power negative 6.
Yes, and then you say plus, and then nano. This is also microman.
Yes.
Plus 10 to the time negative 6, and then you divide by 2, and then it's gonna be 8 plus 4, It's gonna be 12 and then 6. And yeah, it's 6. 6.
Yes,
Confirm. Pella, my math is not make sure.
I
But
did confirm.
wait.
If I may,
The
is
other one,
it advise me to, I'm using like scientific, right? So should I now prefer one decimal place or two?
you must do. Uh, yeah, you cannot. It's better to use 10 times what, because it's the things that they gave you. Use scientific notation.
I'm
Uh,
using scientific notation. It will ask me if I want it in first decimal place, second or third when I'm setting it to scientific mode.
I think you can do 2 decimal places, but this one won't have decimal places, I think. But another thing that you have to note is that you add them with their charges. So this answer is not correct because it has to be with its negative charges. Another one is gonna be decreasing, another one will be increasing. So you must make sure you include the charges in this formula.
It's two, basically it's two.
It's 2 times 10 to the power
Yes.
negative 6. So columns.
This is the formula where I include the charges formula, right?
I mean, I'm not getting you guys, Wambango. I mean, I'm still getting 6.
You are still getting 6 when even when you used negative.
Negative way.
The 4 there, it's
Oh,
negative
it's supposed.
4.
Oh,
So
yeah, it's 2.
it comes with its sign. So you must also note that in the exam that it's gonna come with its sign. So
So when I'm
okay,
to
you can
it,
speak.
I can add their charges only, right?
You say what?
When I'm calculating for Q new, the new charge, this is the only formula that I include their charges, right?
Mm, on other formula, it depends on if you choose direction. If you choose
Sure.
direction, you can include you can don't include the charges because you have included the charges in the direction. But now, if you do not choose direction, you can insert the charges. I will show you in the example that's coming. I think there's an example in which in that example we are going to do that. Yeah, in the next example, I was still looking for the formula sheet. Mm, okay, so it says that draw an electric field pattern due to a due to the two spheres, and then they say we must draw it. What do you know about the electric field pattern? So I think this one, this grade 11 Rachulumera, we know better because they are doing magnetism there. They're doing magnetism where they used to draw. So in magnetism, you must know that at a positive charges, do charges go in or they go out?
Ouch.
So they go out. That's the important thing. So you must know that these two charges, because now they've been separated, they will share the same charge now, which is positive what? 2 times 10 to the power negative 9. So they are going to repel one another. So they are gonna be like this, gonna be like this. Just any way of drawing them. So just any way of drawing them. There's no right way. And then here it's just gonna be upwards, outwards, outwards. They say you act like there's a positive test charge. So a positive will repel a positive test charge. Positive sphere will repel. That's how you must. That's how I used to cram it. So this is how you are gonna draw it, ne? Because they say you must draw a they say or a draw electric field after they have been in contact. So now this is how we draw it. Do all of you understand?
Yes.
Yes.
Okay, let's continue. It says that draw an electric field pattern due to, oh, I did it. May someone read for me the following one?
It's 1.3.
Yes,
No.
1.3.
Okay. After R and S have been in contact and separated, a third sphere T of charge positive one, yeah, microcoulomb. I sorry. I lost the things.
If
Uh,
now placed between them as shown in the diagram below.
Yeah,
mm,
1.4.
yes.
Draw a free body diagram showing the the electrostatic force experienced by sphere T due to sphere R and S.
Okay. Yeah, so now they are saying when the charges are like this, when the charges are like this, now here they are going to put another charges between the very same, these two charges. So this one, they say that it has a charge of positive 1 microcoulomb. Yo, it's hard to write this sign, but okay. This one is going to be 2 microcoulomb also, because this just means 10 times 10 to the power negative 15. And we got 2, there we got 2 times 10 to the power negative 6. Negative 6, man. So micro just means negative 6. This is going to be 2 a microcoulomb also. All of these are positive, meaning that all of them, they are repelling one another. So that's an important thing to note. So they say draw a free body diagram of electrostatic force experienced by sphere T due to R and S. So they need, we are taking T as a point of perspective to say that where will S push or pull T, where will R push or pull T. Let's start between the relationship of R and T. So does L push T away, or which side does R force T to go towards because of its sign?
Right.
To the right, yes. Why? Because opposite,
Because
same
going
side.
to R and they repel, meaning it's going to push it away from where it came from, which is to the right.
Case to the right will be the force of a
R to
T
T to R.
on T. Yes, it's gonna be this side. This is a free body diagram. And then let's talk about S. Where will S push or pull T?
To the left.
Rachel Rumela, are you there? Because you had said you need help with electrostatics. So it's the first of S on T. And then like this is the free body diagram. So there are your marks. Calculate the net electrostatic force by T due to R and S. So they're saying we are using T as a midpoint or as a point of perspective to say that what is the sum of the electrostatic force at that point. So now this is where we solve you will answer your question to say that do we substitute, or when we substitute, do we put signs or not? So my answer will still be to say that are we choosing let's choose direction. The option that I prefer is for us to choose direction and then not put a sign. So for example, now this is a free body diagram in which the F net will be equals to what? Let's take right as positive. Ne? Right as positive. Because we must note that T is being pulled to either side. So which force is pulling right is gonna be F R on T minus F S on T. And then we just come in here. And then when we just come in here, we just say KQ1 or QR qt over r minus kqs qt over r. And then we just come and say, okay, let's see. The k is 9 times 10 to the power 9. The q for r, what's the charge for r? It's 2
Yes.
times 10 to the power negative 6. What's the charge for t? It's 1
That's 1 times
times
10 to
10 to
the
the
power
power
negative
negative 6.
6.
The distance there in r. We must note that we need the distance in meters. So how do we get from centimeter to meters?
We divide by 100.
Yes, we divide by 100. So, and then we just say squared. There's a square, ne? Yo. He. Imagine if it is an exam, you forget the square. And then 9 times 10 to the power 9. And I once did it in my June exam. Yo, I cried. I almost cried. So we must just put the right one. So QS, what is the charge for this one? It's still the same. I shouldn't have wrapped. It's still 2. And then what's the charge for T? It's 1. It's given in the information. And then, to Rachel Mela who just joined, what you must note is that this micro or this U, which looks like a U, it represents 10 times 10 to the power negative 6. So that's why you see us switching like this. So you can press the calculator, but first, because they usually put marks, don't press it all together. First press this one and put it here. Maybe there's a mark for this, but I don't think they
It's
will.
1,8, that one.
This one is 1,8. 1,8, just like that.
Yes.
Okay, and then this one.
I'm not sure. I'm still calculating. I got 0,45.
0.45. And then we come and find the difference.
It's 1,35.
1,35 meters.
Yeah.
So,
Please.
not meters, newtons is a force.
I mean newtons.
To the right, because R is positive, right is positive. So that's how we get it. Did you understand?
No, can you please explain again?
So the key is in the free body. If you draw forces wrong in the free body, you won't know how the F net will be. So you just come and draw the free body and know that, okay, this one is acting to the right, this one to the left, and then to the right is positive, to the left is negative. You say minus that force. And then this one, F of R on T, it represents the force between these two. These two spheres, the sphere R and sphere T. That's why the distance, we even put the distance between the sphere R and the distance between the sphere T, which is 10. And then we put the charges of R and T. So it's like now we are doing just the electrostatic force between just those two charges. And then when we continue, we come at between these two charges, T and S. We do the same. We check the distance between T and S. We put the charges of T and S as is, and then we just come and substitute, and we get this and this, and this is our final answer. Do you understand now?
Yeah, I do.
Do you also understand, Daki?
Yes, I do.
Okay. So yeah, if like they come tomorrow in the exam, the key point is the free body. If like this one was positive, or maybe let's say this one was negative now, there will be two forces acting towards this way, and then now this one will just let me think. There will be two forces. Yes, I'm right. Then this one will come this side, f of s on t, and then it will be plus. Now you see what determines the plus is the
Mm.
direction, to say that now you are adding this and this one is pushing that one that side, this one is also pulling this side, and then you come and work the same way, but the difference is that is the plus now.
All right.
So the key is the free body there. So now, okay, this still continues. What is define electric field at a point?
Define electric field is a point, guys.
There's a formula. You must always know the formula before it can help you describe.
Yeah, electric field at a point. It says it is the electrostatic force experienced per unit positive charge placed at that point.
Yes, just means this definition. So now when we continue, it says that calculate the magnitude of the net electrostatic force at the location of T due to R and S. So yeah, they want the electric field at that point due to R and S. So which formula are we using? There are two formulas for electric field. There's this one and also this one. KQ1 over Q. So which formula should we?
Number one,
Okay, this first formula. And what are we gonna use?
we're gonna use the the F which we got right now, which is 1,35.
Yes. And then
Q um where is it?
the Q is the charge of T, because we are looking at the what T is experiencing times 10 to the power negative 6. Then how much does it give us?
No, 135,000
135
and four zeros.
and
Four zeros.
4 zeros. Okay,
Yeah, 135. No, on a comma.
on a common.
Mm.
135 1 2 3. Okay,
Four
4
zeros.
zeros. Okay, let's try to write it in scientific notation. 1,35. Okay, this is gonna
Times
move
10
1
to the
2
power
3 4 5 6
plus
times 10 to the power 6, and then is newtons per coulomb. Okay, so now, okay, let's see if we can use this equation. I'm curious, Ori. If we use that equation, we have this charge here, which is this very same charge of of 1. Okay, can we use that charge? I think okay. Let's just stick with this one. Let's just stick with this one. Yo, I have unplugged my mic. So yeah, I think let's just stick with this one. Let's confirm really fast. I think it's down there. This is what momentum. This is work. Is this is work before or after electrostatics? It's probably after. Okay, this is linear momentum. I think it's after momentum. This is work again. Wavelength, presumably Doppler effect is it. And then there is question 1. So we got this one, this one, and 1.35 we got it. We used this equation. Oh, this is the second one. They did it like this. They substituted the 2.
That's the longest one, Sham.
Yeah, it's the longest one. But maybe they first found the electrostatic force of the other ones. They've also found of the other one, and then they subtract. They drew a free body diagram of the electrostatic force. They found a force which is pushing it there, and the force which is pushing it there, and then they subtracted. This is important if like they didn't give you, if you first didn't have this value, this one would have been the longer method. But it's up to you. Yeah, but you just have to know that you can deal with the electrostatic inert by the same way that you deal with the electrostatic force. Just need to find the one that pulls it that side and the one that pushes it that side. Is the same thing, but the difference there, I'll show you the small difference when it comes to this. The small difference is that both of them do not include T. We just wrap T. We just wrap T here. We just wrap T. Because T, the formula just said K Q over R. And then you get your inert. You just come in this was minus. I put positive when I was demonstrating to say that if they change direction, then you just subtract the answer that you get from this one. So it's the same procedure, but use this formula. And then you get your inert, you substitute it. You get your inert, you substitute it here, and then you use this Q as the charge of T. You include it there. The Q that you're going to get here, you put it on the top. You keep K as is. So where do you want us to go now? Or maybe it's enough.
Based to me na myself about charges, nandikodo dada hapo ne like you use Fnet. I mean Fnet is equal to FR whatsoever. Ndakodo dada ne puti. But then right now I'm trying like okay. I'm fine with it. So I don't know what bang wako suggest to continue with electrostatic or to move to another topic. Cause
okay. I think we can do the last topic, and then maybe I can help the grade 11s.
the last topic, I was suggesting Newton's law, maragazoza mahara guys, and then they are wrong.
Okay, I think we can do the last one for Newton's law, and then I can help the grade 11. So which ones? Okay, maybe should I scroll through so that you can choose which one you want us to do? Okay, let me scroll slowly so that maybe you can see which one you want to do.
Right.
When you start seeing a person, you know it's going down. Yeah.
Okay.
So you can just choose any of these.
Jehovah. Maybe you to slow you guys graph.
I honestly, I don't know, but we'll find out if you want us to do this one.
Oh,
You don't want to do things that
mm-mm.
don't usually come. Ne?
Yes.
You must.
Let's do question 7.
Question
Number
seven.
1, question 7.
Oh, we must just do this one. Ne?
Mm,
Okay.
okay. It says that Elena constructs a push toy using 2 blocks with masses 1.5 kg and 3 kg, respectively. The blocks are connected by a. Mm-mm. Yeah, yeah, you can see.
Yeah.
The Elena then applies force of 25 Newton at an angle of 30 degrees to the 1.5 kg block, which means of the light region rod, causing the toy to move across a flat, rough horizontal surface as shown in the diagram.
Okay.
So state Newton's second law of motion, Oh, the coefficient of kinetic friction between the surface and each block is 0.15. Then yes, state Newton's second law of motion anyway.
So, state it.
Um when when the net force I don't mean when the net force is acts on an object, the object will accelerate to the direction of the net force. Acceleration is directly proportional to the net force and inversely proportional to the mass of the object.
Okay. Thank you. So yeah. And then they say calculate the magnitude of the kinetic frictional force acting on the 3 kg block. So this is our 3 kg block. Kinetic frictional force. Are we given the mu k? Yes, we have it. Of they say that between each block, or they have the same mu k arc, maybe because they're on the same surface. So what is the formula for the kinetic frictional force? The Fk equals to what? Mu k
You multiply by the normal force.
by Fn. Okay. Mu k, what is our Fn equivalent to?
Mg weight,
Mg.
which is mg.
Yes, our mu k will be 0.15 multiplied the mass, which is they say of
Sorry.
the 3 kg, ne? Multiplied by
Mm.
9,8, and then there it is. How much?
I got 4.41
4
Newton.
4,41. Does everyone understand? Does everyone understand newtons? Okay, so it has a direction backwards. It's always backwards.
Or who calculates, I mean?
Frictional force, or let's just say
Oh,
to the left, because the objects are going there. They say draw a free body diagram for all the forces acting on the object. So the free body diagram is the key when it comes to solving, because it
yes.
helps you find out which forces are you going to include in your calculation. So let me wrap here. So, and then there's our 7.3 free body diagram of all the forces acting on the 1,5 kg. So first is the force, the tension force, which is pulling it back, the tension of this wire, not of this wire, of in inextensible strain, whatever. And then they
Yeah. The
do this
gravitational
of
force. No.
Fk, then there's Fg, then there's Fn, and then there's that force, which is, we always put forces like this, because this one we are going to maybe use that rule, what we call it, vertical opposite. The 30 will come here, and then the 30 will come here. So the 30 will come here with the horizontal through vertical opposite angles, they're equal. So now how many forces do we have? 1, 2, 3,
5.
4, 5. Yeah, usually the forces corresponds with the max. And then I think, is it all? Yeah, I think it's all. And then they say calculate the magnitude of the kinetic frictional force acting on the 1.5 kg block. Okay, so they want the kinetic frictional force acting on the 1.5 kg block. So we just come and say Fk equals to mu k times Fn, uk Fn equals to mg. These are free max, Shem. These are free max. 1.5 times 9.8. Then how much do you get?
Okay. I got 2,21.
2,21 Newton. 2,21. Okay.
At first, when they say calculate the kinetic frictional force, then could be on the wrong way. Because, like, I thought you could show me some F net is equal to MA. Because, ingangari T in angle. Like, yeah, that could do on John.
Oh, wait. Maybe you are up to something. Yes. Thank you for correcting me. Ne? You see? Yes, you see, like, it means tomorrow you'll be chopping the paper.
Oh.
Okay, so you must note that if there is like a fy, there's like fy now, there's gonna be fx, and then
Yes.
there's gonna be, let me just use this, and then there's gonna be fy here, fy. So now looking at that, forces are balanced in respective to the fn. Your fn will be equals to fg minus, oh no, it's not minus, but it's gonna
It's
be
plus
fg plus fy.
FY.
Yeah, because forces going down will balance the ones going up. And then you come here, and then we just try to find this angle. This angle is 30 degrees,
80.
and then it's gonna be opposite over hypotenuse is sine.
It will be cos theta.
Opposite of hypotenuse is sine.
FY mo di ba sine?
Because
Oh, depending or angle
this
uzulisahan.
triangle yoshandaya and
Yonda kutona si
wait. Fy is sine because opposite of hypotenuse. So you must always
sine.
check the angle. Where is the angle? That's the most important part. Here we are using like to say a vertical opposite from this diagram. From here to
Yes,
here,
I can see.
the angle will be here. So now we just come and say that, fg plus fy, fg is mg, and then we just come and substitute here. Let me just write fg minus fy or plus fy, and then I come and wrap here. So you must note this, that every time there's like fy, fn changes, because like this fy is helping pressing the block a little bit down, making fn larger. So now fg is going to be equal to mg. The mg equals to 9,8 multiplied by the weight 1.5, and then there will also be the fy, which is this force 25 sine 30, and then this we get our answer. How much is our answer?
Sine theta. I got 14,71.
You got 14,71. 14,71. 21 sine 30. Okay. There's also this and this. Yeah, but do you understand what does everyone understand what we did here?
Mute.
They're muted. Okay. There's no problem. We can just continue. Now, when we continue, it's draw the the tension in the chord of the two blocks. So the tension
Yeah.
here, usually tension and acceleration, you find them together and you use simultaneous.
Yeah.
So now you have to have the forces on the two blocks now. So there is the forces on a block 1.5 and then the forces on block
3 kg.
3 kg. And then now you just say F net, this Newton second law that we used there. The right
Yeah,
is
this
positive. And then we just come and substitute here. And we substitute to say that which are the free body, that one that we draw on the 3 kg, or we didn't draw the free body here. But
yeah,
we
we
can,
draw the one of 1.5 kg.
okay, thank you. We just need to know the forces acting on the right is tension, is pulling it to the right. Then the one acting on the left is friction, pulling it backwards, Fk. So is there any force that I left on the 3 kg? Or this, let's make it this one the 3 kg. And then we'll make this one the 1.5. Okay, kg. So is there any force that I left here?
No, the 3 kg is over there.
Okay, and then I just come and say this will equal to MA, and then tension minus this. So the tension, I'm looking for it. The mass, let me substitute the mass here as 3, and then minus the Fk. I calculated it. So for the 3 kg, I think I rubbed it. But we calculated it somewhere
The
here.
what?
Oh, 4.14. The frictional force for the 3 kg. 4,41. And then we come here. So you understood that side, ne?
Yes, I did understand.
Okay, so we come and substitute here to say that here is the one to the
Yeah.
right is Fx,
Yes.
and then minus Fk minus tension equals to Ma.
You know, I was going to get something wrong. I always thought you could do fx minus fk plus t because fk na t zika said in t. I was going to say fx minus fk plus t.
Oh, if you
But then it needs me
wanna say plus
to
t,
include them in the brackets.
yes, you should do this. Yeah, if you wanna add them, that's what you should do. But now you should keep them like this. But if you edit it, would have been like t this side. So
Yes.
yeah, and then now when we come to the f at x, we say that we come to this this form this free body diagram to say that now it's adjacent over hypotenuse is cos now. It's
Yes.
f
mg
cos.
theta.
Yes,
mg cos theta.
yes, cos theta. And then you see why did you go for mg?
I say mg cos theta.
T, no, it's just a triangle. In a triangle, you just write it like this, the way that it appears in the triangle. Yeah, you write mg cos theta in an inclined plane when you are looking for the fg perpendicular. Yes, but here you just write it like this because it's just to say that we are just using cos to say that the cos theta will be equals to the adjacent f at x over the hypotenuse, which is what? Our f. We just make our f the subject to the formula, which will be equal to f cos, it will be equal to the f at x will be equals to f cos theta. So in place of the f at x, we are going to put f cos theta like this. And
Okay.
then we say plus tension plus ma, and then we just come
So
in.
it's going to be minus tension. Positive multiplied by
Yes,
negative.
positive multiplied by negative. Thank you. And then the f cos theta here. We just what is our f? Our f is we are given is 25. What is our cos angle is 30 degrees here. And then we just come and substitute minus what is our fk? Our fk, we calculated it for the 3 kg block.
14.71.
14,71. This one.
Yes, yeah.
14,71 minus t equals to the mass 1.5 a. What are we looking for? We are looking for the
T.
tension. So it means let's get rid of our a's in our equation. So now, in order to get rid of our a, we just come and divide both sides by 3. This side, this is our first equation. Come and divide both sides by 1.5. This a, and then this cancelled by this cancels this, and then it will be a equals to t minus 4,41, and then this side is gonna be a equals to 25 cos 30 minus 14.71 over 1.5. And then in both equations, because those
T, you left T.
Okay, thank you. In both equations, because our a is the same, because they are connected by a string, it means that now the acceleration is the same. A equals to a. We just equate now. We say t minus 4,41 over 3 equals to 25 cos 30 minus. There are different ways to solve a simultaneous, but as long as you get to the answer, 1,5, just cross multiply 1,5 into t minus 4,1, 4,41. I'm just cross multiplying this and this, and then this font is too much, but it just showed. And then 3 into 25 cos 30 minus 14,71 minus t. And then now what we are gonna do here is just this one is gonna cancel this one, because it's not gonna cancel completely, because here we are gonna left with 2, because 1,5 gets in 2 times at 3, ne? Just have to find faster ways to get to the answer. And then this side is gonna be 2 times 25. It's gonna just be 50 cos this multiplied by this.
Let me do it like a jota.
But this t this side, this t, you can do it together. What you have to do is that what you can do though is just to do 2 of these except t. How much does that gives you?
Then I got 28,59.
28,59, eh? Okay. So you did like this. Okay, you
2 times 25 plus 30 minus 14,71.
Oh, so
25 cos 30 minus 14,71. I'm getting 6,94.
Why am I getting different things? What did Daki say?
When I did on my calculator, it's 2 times 25 cos 30 minus 14,71.
It's how much?
Right?
No, so wait at 2 times. So wait at 2 times.
Did you do brackets in 25 cos 30 minus 14,71? That must be in brackets.
Yeah, I'm getting 6,94.
So what did you do at this? What did you put on your calculator?
I put
Okay, Faith, did you include 2?
no,
Okay, man, I
not
included the 2 but
You said six
6,94.
6 comma what? 94. Okay, we'll move to the step of including 2 now. Now it's gonna be 2 times this, 2 times this. It's just gonna be 13 point
Okay,
how much?
13,88
88 minus
minus
2t,
2t.
and
Yes,
then t minus 4,41, and then we just come and take this one this side, that one this side, and then this one is gonna be 3t, this plus this 13,88 plus 14.41 is 4,41. Okay,
I got
14.18
18,29.
divided by 3, and then divided by 3,
6,09.
1.
6,09 is it newtons. So this is our tension. So do we still have another question? I think it's the last one. Let's just go and confirm, and then we will be done. Newton's law is the first one on the memo.
Yes, finally.
Let's just check the memo. There it is. It's this one.
Mm. Hmm?
No, they're not close.
No,
It's not this one.
no. Mm. We did
Oh, we did
question. I think
question
it's question
7.
7.
We did question 7. Let me just copy it
Yes.
and then bring it closer to where we're solving. I should have used this thing on the side. It's fast. Okay. Let me just paste it here. And then there it is. So starting from there at the beginning, okay, it's here. The resultant force we there 4.41, and then 4,08. Okay, this one we got it. This one we threw it. This one we throw it. Oh, wait. This one we didn't get it. This one
Which one?
7.4.1. You see a 7.4.1. This one,
7.4.1.
yeah, these two here, these two, these two, yeah, these two.
We got 14 comma something.
We got
We're
14.
calculating for what?
We are calculating for the frictional force, the one that you said or use. Wait. The one that you said that we must consider that now there is a y side. You remember it? Yeah, it's that one. So let's bring it closer to this one and compare. So this is our wiki. There's our wiki. So let's see. What's the difference? As we are supposed to get this one, 4.4,08.
We included FG and opponent corner we include FY base.
No, they just put these ones this side. You see, these ones they just shifted this sides.
Oh, that's not sure.
It's the same thing. I think try pressing the calculator again.
Okay.
Yes, 4,08.
Yeah, we were supposed to write 4,08. So, yeah, it means you made a mistake, Chris, pressing the calculator. So, it means it's also going to affect the following answer because we substituted this answer here. You see?
Yo.
But it means maybe we can come here, we just change here, rub here, and put 4,08. And then we'll see. Let me just put 4,08 minus 4,08. And then how much is 25 cos 30 minus 4,08?
17,57.
17,57. And then 17,57. And then now, what did
It's
we do?
35,14.
35,
32,14.
35,14. And then this is also 35,14. 35,14.
39,55.
5.
39,55. How much does it give us?
13,18.
13,18 newtons. Let's see what the memo says. The memo says 13,1 oh 13,19. Yeah.
It's only the same thing.
Yeah, it says from 13,17 to 13,19. So it means it's within the range. So
Yes.
yeah, the answer that we get is correct.
Pleasure.
Okay, I think we'll end here for today. You can go and revise, and I will be left with the grade 11s. Ne?
Okay, no problem.
Document to Faith. Faith will send it to me.
Oh, you mean this document I'm doing now?
Yes.
Okay, yeah, okay. I'll send it now.
Mm.
Okay.
So wait, is it possible for me to join with the grade 11 so like with some revisions that I need from grade 11?
Okay, no problem. Let me see if he's engaging. Rachel, Rachel, hello? Rachel, you are not audible. The mic is not working or something. Hello? I'm not able to hear you, and I think it will be unproductive if I'm just speaking and you cannot hear me. Try changing the device. You are not audible. Try changing the device. Try changing your device. Yeah. Okay, in the meantime, I think let's just wait maybe 5 minutes for you. Maybe if you have any questions, you can tell me. Or maybe if you want me to help you with something in the meantime.
Let me show.
What are you saying?
Oh, this is conservation of energy with non-consecutive forces present. I think it's part of work energy theory. Yes.
Or work energy and power? Conservation and okay, conservative forces and non-conservative forces. Okay, so in the meantime, when we wait for Rachulumela, okay, we can go to it. Do you want us to do this question paper on work energy and power? Or do you? Oh, first, what you need to know about what do they call them again? It's non-conservative forces and conservative forces. Yeah, conservative is someone who like, oh, I see. Oh, I think there was the say. Oh, I see. There's someone who texted in the chat. Yeah, Newtons. Who said? Oh, somebody. Oh, there's a chat. I must pay attention to the live chat. Where is your face, please? They wanna see my yo. If you okay, my face. Just that it's like at the night, but during the day, I can go live with my face, and I don't have good lighting in my room. So if I get good lighting in during the day, that's when you'll see my face. They say, what are you reading? Okay. So, and then when it continues, it says that, oh, conservative forces are forces that are like, they stay the same regardless of the path that they take. They stay the same. Just like if someone who doesn't like, maybe someone like the traditional way of doing things, they don't change according to the culture. They call that person a conservative person. They oh they call that person a conservative person. Is someone joined the call? Or you raised your hand, Rachulumera. Try say something. Try saying something. I see. Okay, you can use another device. Try saying something. We are not hearing anything. Okay, in the meantime, I'll be explaining. You can just be trying to speak, I'll hear you. So now, conservative forces is a force, regardless of the path that they take, they'll still have the same magnitude. But the non-consecutive forces, they are forces that they depend on the path taken. So is that the way that they define it is that non-consecutive forces are forces in which the work done in moving an object between 2 points is independent of the path taken. To say that it does not depend, regardless whether the path is long or is shorter, they are still the same value. But when it comes to what we call non-conservative, is its work done in moving an object between 2 points is dependent. The difference is dependent and independent. In non-conservative, we say dependent on the path taken. So, for example, the ones which are non-contact forces, the one that act on an object without touching the object, they are usually conservative forces. For example, it's gravity, your electrostatics, and also magnetism. Those are the forces that are conservative. They don't change regardless of the path taken. But when you come to forces that are usually contact, your friction and also your contact forces, applied force, those forces depend on the path in which they take. That's why sometimes in work energy and power, for example, let's say an object is going down the slope, you can calculate the gravity using this one because it will be Fg parallel, or maybe you calculate the gravity like this, which will be your Fg. So you can calculate it using your y or using your x. But because it doesn't depend on the path taken, it's a conservative force, it will still give you the same answer. For example, if you are using, you have, they say find the gravity, and you are given the height of the slope, you can use this distance of this height of the slope. If you are not given this one enough information to calculate the FG or parallel. So I see Rachel Mela, you are keep raising your hand, but or you say I have requested to join, please accept. Do you accept anyone here? You are in the call. You are in the call. I don't know, like, if you are having a problem speaking to me, uh, speak to Renda to give you my personal numbers, and then you can call me through my WhatsApp, and then we'll be talking through my WhatsApp, and you'll still be looking at your screen because you are not audible here. Yes. Okay. So in the meantime, I'll be explaining to you, ne, Uri, you are still there, ne?
I'm still available.
Yes. So did you understand about conservative and non-conservative?
Yes.
Yes. So usually, a person or maybe a man who says, uh, "I don't pay for, I don't let a woman pay for me in the dinner date," or something like that, or maybe the one that says humans to stay at home, they are usually called conservative because they are staying with
Still believe
the olden ways of doing things. That says that a woman should not go to work, things like that. They are usually called conservative. Usually, even these forces, conservative just mean not changing or staying the same. Ne? So, and then now, if we let's try to be looking at the problems. Let's try to be looking at the problems of work, energy, and power. I think, okay, is what which is this work? Yeah, this is work. It looks more like Newton's law. That's why it was confusing me a little. So, which one do you want us to do? Maybe just choose any of these, or maybe if you want me to go back, you can. I can go back.
let's do question 3.
Question 3. You can read the scenario there.
The diagram below shows a block of mass 100 kg sliding down a rough 25-degree inclined plane. A constant force is applied on the block parallel to the inclined plane as shown in the diagram below, so that the block slides down at a constant velocity. The magnitude of kinetic frictional force between the block and surface of the inclined plane is 226 meters. 3.0. Friction is a non-conservative force. What is meant by the term non-conservative force? Okay.
Okay.
Non-conservative force is define a non-conservative force as a force for which the work done in a moving object between 2 points depends on the path taken.
Yes, it's correct. Yeah, it's correct.
3.2. A learner states that the net work done on the block is greater than 3.2.1 if the learner says yes or no.
You did you answer?
The
What do
learner
you
states
think
that
about the answer of this learner?
let me read it again. The learner states that the net work done on the object is greater than
What would you think if that is the learner correct, not correct, or
not correct.
why would you say they are not correct? the reason, okay, the reason that you must give ne, is that the learner is not correct, because it says that the work done is greater than zero. But if you check here, they say that it's moving at constant velocity. And what you have to know about constant velocity is that in constant velocity, the net work done is equals to zero. So it will be directly equals to zero. It won't be greater than zero, because till we know that work done is equals to change in kinetic energy. So because work done is, oh, I see Renda, you have joined the call. Hello, Renda. Hello.
Hello, sir.
Oh, okay. It's you, ne? It's Adzimi, ne? Okay. Let me finish explaining this, and then will go to focus on it. But I think I'll just explain this one, and then I have sent to Faith this question paper. There's also the memo, and then you can see, get your way around there. If you have questions, maybe you can send through Faith. Okay, so
Okay.
I'm talking to the lady. I'm finishing talking to her, and then I'm coming to you. I'm just answering the last question. So W net equals to change in kinetic energy. So because here kinetic energy is zero, at constant velocity there's no kinetic energy, there's no change, because it is always constant. It means that now when it comes to here also, the answer is no. Explain your answer, because there's no change in kinetic energy and the constant velocity. That's the answer you're going to give. So unfortunately I have to help him ne, on, oh yeah, on some questions. So what do you want us to do, Adzimi?
Sir, can we please go back to electrostatics, and then maybe after electrostatics we'll do electromagnetism.
Okay, I can do electrostatics, but electromagnetism, I still have to prepare, because I didn't know that I was going to have a grade 11 class today. But electrostatics, we can definitely do it here now. Okay?
Okay.
But unless you have another topic suggestions, but I think we can go to electrostatics. So you want us to do some questions from question papers, ne?
Yes.
Do you have a question paper you want us to do?
No, I don't have one. I think I'll use the same one you're using, and then I can see your screen.
Okay. When I say question paper, just mean you can tell me the year I download, or you can, but let me just download a grade 11 paper and then upload it here, and then we'll solve, because this one is a grade 12, but usually on electrostatics they they are the same. It's just that
Yeah.
some of them, they are more in 3D, but I think you, in your level, you only do straight lines, the charges that are put along a straight line. But let me find this question paper. Wait. Okay, here it is. It's still loading. It is a question, it's a question paper in memo. I just downloaded it now. Okay, and then there's your electrostatics there.
Yes.
Okay, yes. So it starts from here. And then it says that two spheres P and Q are placed on an insulated stand. and then carry the charges plus 5 and minus 5 respectively. What's making me smile is that this very same question was there in the grade 12 questions to say explain why the charges are placed on insulated stand. You see, these people are repeating grade 11 questions in grade 12. So what did you learn? Were you hearing me when we were doing those grade 12 questions?
So you were on and off because the device I was using, I think it's damaged. It's cooked.
Okay. So maybe give it a shot to say that what why is the reason why the charges are put on an insulated stand. Give it a shot, give it a try.
Maybe to avoid the charges to being leaked, to avoid leaking of charges.
Yes, that's the correct terminology. To avoid the leaking of the charges or to avoid the charges from being lost. So, and then they say that these charges are brought into contact and then are separated. Are electrons transferred from P to Q or from Q to P during contact? Give a reason for your answer. What would you say about the electrons?
I think the electrons will be transferred from Q to P because Q has an excess of electrons while P does not have enough electrons, or it has a deficiency of electrons.
Yes, it's like that, to just say that this other one has more electrons access, because it's more negative. Charges are transferred from the one that is more negative to the one that is less negative. So far we are on the same page, ne?
Yeah.
Okay. May you read the wait. Something happened to the screen. Okay. May you read the following questions?
Calculate the number of electrons.
Calculate the number of electrons transferred. So the first thing is that, as we have discussed, that electrons are going to move from the 8 the 8 one, and they are going to move to the what? They are going to move to the 5 positive 5 ones. So let's check.
Doesn't this question need that formula for the new charge? Like that one that divides by 2?
Yes, it's gonna need that that equation, but you must also note that there's also an aspect of electrons transferred. To say that electrons transferred, you must look at the formula.
Okay.
There's another equation that you also use when it comes to the electrons transferred. So
Sorry to be
uh,
aren't you going to the formula that says M is equals to delta Q over small letter QE?
a delta Q over small letter QE. Yes, you are gonna use that same concept, but we first have to find the change in Q. For example, let me check if there's a formula sheet here. If it is there in a formula sheet, where is the formula sheet? Okay, there it is. So N over QE, we are going to use this. But now when it comes to that very same equation, we are gonna find the change. We're gonna find the change. When it comes to the number of electrons in if they were to say calculate the number of electrons in a sphere, you just use this. But if they say the number of electrons transferred, you say N equals to change in Q over QE. That's a very much important thing. So
That's-
what?
Yeah, that's the equation that I was talking about.
Oh, okay. And then you must note the formula that you mentioned, Rachurumera, is this one of saying that this change in Q is gonna be Q new minus one of the Q original.
Yeah.
So the one that you mentioned is the Q new, which is Q equals to Q plus QP over what? Over 2. So you must, this is the Q new minus Q original, or you can put it the other way around, Q original plus Q new. It's up to you. So now you just first have to find the new Q using this formula. Q this, you must remember what micro means. You must get into the exam knowing this. Let's say that micro means 10 times 10 to the power negative 6. And then this, the sign here, minus 8 times 10 to the power negative 6. You must go to the table which writes what everything represents, and then now you solve. So what is the answer here?
So we're going to say the answer will be. Oh, I must put it in scientific mode, ne?
Yeah, it's better you put it in scientific mode.
Okay. So the answer will be negative 1.50 by 10 to the power of negative 6.
Okay, yeah, okay, negative 1.50 times 10 to the power negative 6.
Yes.
Okay. So now that's our new Q. But note that it's gonna be negative. Note that, but our change is the difference from where it was to where it is right now. So let's check any of these. The change is always gonna be the same. It's always gonna be the same for both sphere. You can choose any of this sphere. You will just say that, okay, from here you just say Q new, and then you just say 1.5 times 10 to the power negative 6, and then from the change you just say final minus initial, and then let me just say any, just say minus the initial one. This one is gonna be how much? Let's just use the 8 times 10 to the power negative 6. How much is the change? And then let's also test the change when we have used the other one to say that is there a difference. Yeah. Minus, they have to be the same. The change is the same if we are on the right path.
The first answer will be 6.50.
6,
And the other one is negative of what you said.
oh, the other one is positive, the other one is negative.
6.50 by 6 to the power of 10 minus
Oh,
by
6.50. Oh, is micro
minus
column
6.
is the same as times 6 to the power negative 10. Yeah,
Yeah.
so you see the change, of course, this one is negative, this one is positive, ne?
Positive,
This
yes.
one is negative. Yeah, it's fine. It's the same unit but different units, because the same the same value but different signs. Because what? Because as we have said that charges will be transferred from Q to P, which means that this one is gonna lose negative 6 plus negative 6 comma 5 times 10 to the power negative 6 electrons. This one is gonna gain 6 comma 5 times 10 to the power negative 6 electrons. You get it? So it's the same because another one is gaining, another one is losing, but it's opposite sign because another one is gaining, another one is losing. So, and then they say the number of electrons transferred. Now we come and use the difference now to say that, okay, because these are the charge which is transferred, the charge which is transferred will give us the number of electrons which are transferred. And then you say and then over number of electrons, which is 1 comma, is it 1,6 times 10 to the power negative 19? But let me just confirm it. I don't have to stress when I have this. Is here, yeah, 1,6 times 10 to the power negative 19. But here they put it as negative. But here we are looking at the number of electrons. The number of electrons doesn't need you to write negative or positive. So you just come and substitute this. And how much do you get at the number of electrons?
We get 6.5. I got 4.06 by 10 to the power of 30.
4.06 times what?
10 to the power of 30.
10 to the power of 13. So these are the number of electrons transferred. Is there anyone who does not understand? Do you understand?
Yes, I did.
So yeah, it's very much important. When they say the number of electrons transferred, you find the change, which is final minus initial, and then you get your answer. But if they say the number of electrons in the sphere, you just take your Q to be the Q of that sphere. It doesn't have to be the change.
Yeah.
Yes. So now they say name the law in question 7.1.3. Which law were we using?
Coulomb's.
Coulomb's law. Is there Coulomb's? Did we ever use Coulomb's law here?
No. We didn't use Coulomb's law. Wait.
T Coulomb is K equals to Q1, Q2 over Q.
It means we used what is the ohms? Did we use ohms? No.
No.
No. Sorry.
Ohm is in electric circuits. So
It means
I think it's electricity.
you said what?
But don't you think it's Coulomb's law?
Don't I think it's what?
It's Coulomb's law.
Coulomb's law is K equals to Q1 over Q2 over R squared. We never used that one. So you must remember all the laws that are there in electrostatics to say that the law that we used is law of conservation of charge. That says charge can never be created or destroyed, but can only be transferred to from one sphere to another. Or to just say this charge of a sphere of an isolated system remains constant. So that's the law that we have used.
yes.
That's the law that we have used.
There's this question like no, not the question. Can I be in grade 12? Can they ask me about the question about the law I used?
I don't think they will, but if they do, you must check which if like Coulomb's law you used specifically it's there, it's fine. You can write Coulomb's law. If another law is there, you can write it. But if there's no law, in principle, that is always there in electrostatics is law of conservation. Even in Coulomb's law of conservation is there because charges is not being destroyed there and charges not being created, but it remains constant. If they didn't mention Coulomb's law specifically, you go for law of conservation of charge.
Yes.
Okay, so let's go down. 7.2, it says that R is a point of a charge, and then they say plus 6 nanocoulombs, and then they say draw an electric field pattern around a charge. So it's similar to what we had there. You see, electrostatics didn't really change.
Yes.
Where do the arrows point in a positive charge?
They point inside.
They point,
Outside.
yeah,
Inside.
they point outside. You must always note that always a positive charge, it goes outside. So you must always know that it's positive. In grade 12, I don't know if it is in grade 11, there's something called a positive test charge. So you pretend as if like there's like a positive test charge always, which is gonna be repelled away. Positive and positive repel. But if they say draw around a negative, then the positive charge will be drawn near. Negative, they always go inside. So that's a way that you can use to remember. But if you can just remember it repel without remembering the positive test charge, it's still okay.
Yes.
And then it continues to say that S is on this same point at the magnitude of negative 9 nanocoulombs placed on the 25 millimeters to the right. You see, in grade 12 we were doing this very same thing. It was this very same straight line, but I think this one is Z is a test charge. This is a point charge. The difference is that this one is a point charge. And then they say S is a point of magnitude of a negative 9 placed 25 millimeter to the right of R. And this is Z is a point X X millimeter point charges. R and S point Z lie on the same line, or they're all on the same line. State Coulomb's
Yes.
law. What is Coulomb's law?
Coulomb's law states that the magnitude of an electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of distance between them.
Yeah. That's how we define it. And then they say calculate the magnitude of the electrostatic force that charge R exerts on S. So this one is we are given all the information, the charge, we are given the length, we are given everything, but what we just have to do is just to calculate. And another thing is that we have to know what nano represent. What's the value of nano? And nano
Isn't it negative 9, 10 to the power of negative 9?
is 10 to the power negative 9. It's very much important. You must know that table. And then from the distance must always be in meters. If it comes in centimeters, millimeters, everything, you have to be in meters. What do you do to move from millimeters to meters?
We must divide
By how much?
by 1000.
Yes, milli means 1000. So divide by 1000. So we are ready to go now. We just come and say um, FRS equals to KQ. Our K is 9 times 10 to the power 9. And then we come and substitute now. We just say it's gonna be 6 times 10 to the power negative 9 plus, we don't write signs here because they're just looking for the
It's
force. 9 times 10. Oh, you when you are saying it's, wanted to give me the answer.
yeah, but then it was a wrong one.
Why do you say it's a wrong one?
Because you wrote the answer.
Or why? Or you wanted to tell me to substitute otherwise?
Yeah, I wanted to say another value, and it was a wrong answer.
Where? Where have
They
you?
at they at 9 by 10 to the power of -9.
Or you wanted? Oh, okay, no problem. Okay, yeah, you are also free to use Venda. You can also use Venda. Yeah, if you want to use Venda, nanende Venda.
Yeah.
Okay, so like you can press the calculator, then we get our answer.
Oh yeah.
What time are you going to sleep?
Today we don't sleep, eh?
You are you are writing tomorrow.
Today we don't sleep.
You know rest is very much important for optimal brain functioning.
Yeah,
Agreed, but
I'll
it
try to
requires
sleep 3 hours.
Yeah, I try to
Mm,
try to sleep because it also helps with the way that you are thinking. But if you don't know the content, you must try to catch up, but also rest at the same time. What were you saying, Ducky?
the answer
remember
before Daki, sorry. The answer is 1.94 by
One
10 to
point
the power of
nine four
minus 1. -5. So
times 10 to the power what?
-5.
-5.
first then you got the different one. I was just waiting for your answer.
What? How much did you get?
I got 7,8 times 10 to the power
7 comma what?
7,8 times 10 to the
10 to the power what?
-4.
So I don't know. I don't know who must press the calculator again.
Oh,
So
it's me. I didn't square. Yeah, it's
yeah,
me. I'm sorry.
yeah. You must remember
Sure,
a square.
Yeah,
Even
it's 7.78. Yeah, she's right.
even tomorrow, remember the square. Because if you don't remember the square, silly mistake. So and then yeah, this is our answer. So let's just write it here. 7,8 times 10 to the power -4 newtons. And then they say the net electric field at point Z is this one. So there is a net electric field. And then they say calculate the value of X in meters. So we were just doing the E-net there in grade 12. So there are two formulas for calculating E-net. E-net equals to force over Q, and then E-net equals to a KQ1 over a R squared. So this one of Q, it is the charge of Z here. So we are not told the charge of Z. So it means this formula is out. This formula is out because we are not given the charge of at Z. If we knew the charge of Z, we would have just used this force and substituted here. But now,
Yes.
because we don't have that charge on Z, we just have to use this formula now. What does this formula mean? This formula is the net force due to S and the net force due to R. So there is that point where you need a free body diagram. You need a free body diagram to come and say, oh, this formula can still work. It can still work in an E-net of a section. But let me think. Oh, okay.
Sorry. Can
Oh,
you still hear me?
yes, I can still hear you.
Hello.
Hello? Yes, I can still hear you.
Can you still hear me, sir?
Yes. Can you hear me? Can you hear
Yeah,
me?
my
Am
internet connection.
I audible? Is it my internet? Can you hear me?
Yeah, I think now I can hear you. Can you hear me?
Yeah, I can hear you. Is it fine now?
Yeah, it's fine.
Okay, Daki, can you hear me? Okay, so now um, what we have to do here is just to find the E net from here to here. The first thing to do is draw a free body diagram. That's very much important. To say that at point Z, this is point Z, and point Z, we take it as a positive test charge. That's very much important. So if we take it as a positive test charge, even though they haven't told us, unless they say otherwise, unless they say it's negative, we take it as a positive test charge. You get me?
Yes, yes,
Yes. So now what what is the relationship between this negative and this positive? Will it attract or will it repel?
negative and positive, they must attract each other. Opposite
So
attract.
S is gonna attract Z to where? That side. S is gonna pull Z that side. So is the innet of S on Z. You get me?
Yes,
And then there will also be the force of R on Z. R is positive, Z is still positive. It means it will do what? Repel. Ne?
yes,
Yes, because Z, we said we take it as positive unless stated otherwise. It will be the innet of Z on R. Oh, the innet of R on Z, the other way around. The, the innet of R on Z. So
yes,
far you're with me in the free body diagram, ne?
yeah,
Now the free body diagram
yes,
is gonna help us find the the distance. How is it relevant? The innet, which is this one, the one that we're given, equals to a, let's take right as positive. Right is positive, to say that because force of E net of R on Z minus, because this one is going to the left, E net of S on Z. You are with me so far, ne?
yes,
Okay. And then now we come and say that, okay, in this one, innet, we have it. What is our innet? 7,66 times 10 to the power 5 is this one we're given. We are solving for what? We are solving for
for
our x,
Z,
this distance here.
X.
Okay. And then now our innet of R on Z. So let's look at our innet of R on Z. We'll just come and say innet equals to KQ1 over R squared, this formula. Our K is 9 times 10 to the power 9. What is our Q1? Q1 is just this one. We write it as is, and then we just come and say 6 times 10 to the power negative 9 over this distance, which we just said is 25 times, or we can say times or divide, but if we say times, we just say times 10 to the power negative 3, because it's the same as dividing by what? By 3, ne? By 1000, ne? Is the same.
Yes,
And then
yes,
we come this side, S on Z. That's when we just come and substitute on this very same formula. We are substituting on this one here, and saying 10 to the power 9 into our negative 9. Oh, we don't put a sign because a sign we put it in the direction here. And then we say times 10 to the power negative 9 over the distance is x. But you must remember that we are looking for our distance in maybe in meter or in millimeter. But if we just leave it as x squared, there's a square. It's very much important.
Yes.
If you just leave it as x, you will get it. You will get your distance in meters. But if you were to substitute and say x multiplied by 10 to the power negative 3, you will get your distance in millimeters. But now let's get our distance in what? In
meters.
In meters. So now this is a matter of just solving now. Instead of just battling with maths. So you just take this one this side. Or maybe you take that one that side. You just say, okay, now I wanna what's this multiplied by this? These ones which are on the top, how much do they give you?
The ones on the top, is that a minus 9, sir? Is that a minus 9?
Yes, it's minus 9.
Minus 9 by 10, minus 9. They gave me 8.10 by 10.
Are you rounding? You are rounding, ne?
Yeah.
Okay, let's avoid rounding because it's not the final answer, ne? So let's just write it like this. We'll just see where it leads us, ne? Okay, I just put this one this side and then took this one that side. 9 times 10 to the power 9, 6 times 10 to the power negative 9, and then this one I just said 25 times 10 to the power negative 3. So here there's gonna be a lot of maths here. There's gonna be a lot of maths. 5. Okay, and then now when it comes to this one, I just have to please press everything here now. Press everything here and try to find a fraction. Give me the answer in a fraction.
In a fraction form.
In a fraction form.
Okay. But it's going to be hard because the calculator is in scientific mode.
You can okay. Let me.
Maybe I'll first turn it back to normal mode.
Yeah, you can try that. Okay. While you're calculating, I'm coming back, ne?
Okay.
It's not in fraction forms.
So cool.
Wow. Ka normal, nende isa ka normal yung pa number. Ka scientific you compare in scientific.
Hey, yaar, dili pasa rolipha, hey. Yeah.
Hey.
Okay. You say it's not giving you it's giving you a number.
Tara nde isa ka normally you compare number, nde isa ka scientific you compare scientific.
Okay. So give me the answer. Maybe give me to 5 decimal places.
Kinga scientific.
Give me in scientific.
8,5204 0 times 10 to the power 5.
Times 10 to the power 5.
No, I iri 5240 0.
52400.
Yes.
Okay, we can keep it like that.
No, it
Remove
says
that
4,
zero.
then 0.
524. 524.
4,
Remove that
0,
zero in
0.
the middle.
Oh, okay, thank you. Okay. Okay, I'm gonna cross multiply and then over 1. Then after cross multiply, this multiplied by this. This is gonna be 9 times 10 to the power 9 times 10 to the power, and then paste that in a calculator. I skipped a lot of steps. I won't be surprised if you are confused. No, I skipped a lot of steps, but I just wanna
Okay, so answer ikotia the calculate decimal place 5 now kana 2.
just give me 2 decimal places.
Mm, 9,5.
You got x equals to 9,5.
9,50 times 10 to the power minus 5. Ati sure hapo oyo mungwe wana wangana.
Nawo muṅwe noni ha ngo vhuya edzisa.
Vana mumwe hone a edzisa fari vhone.
Mara calculator arali hu cashier i ḓo bvisa zwithihi.
Ai.
muthu khou funziwa mara u khou ita zwo bvafha.
Nah, mara eish.
There's something called to verify.
Eish. Ndi khou teledza u zwifha like habe nda ḓo amba nda ri yo bvisa heneyo because
Okay, so I also got the same answer. I think now we can just go and verify our answers and then we'll see. Okay, let's go and verify. If we get to... Okay, it's question 7. So this one, we got it, 4,063. The law of conservation. This one
even the first one we got it.
Or even the first one. Okay. Yeah, has excess electrons. Yeah, remember you saying it. And then this one, the magnitude of the force, we got it.
Even the drawing.
The drawing. Hey, you want everything, I'm playing. And then this one, did we get it? This one.
7.78, yes.
Okay, let me just copy this and compare up there. We got... Where is it? Did I write it down?
7.78.
7.8. Yeah, we got it. Let me check the last one. I think it's a bit tricky. So the last one, they got they got 0.01.
Kanjani.
It means something is wrong somewhere. So
Let's compare.
Yeah, let's compare. Let's compare starting from the substitution. This is this. If you check this here, it's this. Now let's check if the substitution is the same. Is everything the same there?
Give me first.
Oh, I see where I made the mistake.
The 54, ne?
No, it's not that it's 54. I see where I made the mistake. You see, the distance, I only made a mistake when it comes to the distance, because everything else is correct except this distance here. And also when it comes to this side, let's see, this one is this one.
Everything is correct.
Everything is correct here. I only left this plus x. What I did here is that from here, I shouldn't have taken the distance from here to here. I should have taken the distance from here to there. I should have added 25 to plus x also. So it means the distance from R to Z is 25 plus x. You see the way
Yes.
I made a mistake. So do you also see where I made a mistake, Rachilumera?
Yes, I do.
So you must also remember it tomorrow in the exam to say that if this you are measuring innet or the force of R on Z, you must take note not only of the distance between these. We didn't, because I did not account for this distance in from R to Z. I must add them. So yeah, you must remember that. So yeah, that's why we get an off number. So but the rest is correct. Do you have anything else you want us to attempt?
Nah, I would like us to attempt electromagnetism.
Oh, electromagnetism. As I said at the beginning, that I didn't know I was going to be teaching it today, so I haven't looked on it ever since I passed my grade 11. I think now I have 4 years.
Yeah, I understand.
Guys, let me leave you. Let me love you and leave you because now I have a crossover starting at 11 o'clock.
Yo, you guys are not sleeping, eh?
Yo, the class that I'm doing right now doesn't need to sleep comfortably. So rest 1 hour, I wake up. Rest 1 hour. Hey, it's a
Yo.
busy.
Okay, all the best, ne?
Okay, thank you. I will inform you tomorrow. Will you be teaching chemistry?
I will discuss with Faith.
We don't have to discuss with Faith. I'm also here right now. Because that you do another but then we need a one Wi-Fi hour
Okay.
24/7.
I'm not sure about chemistry. I'll let you know. I'm not sure. That's why I'm saying I will tell Faith.
Alright. She gave me your number, so I'll text you so we can talk about the classes.
Okay, I wanna try it.
Hey, sharp. Because I think you're sharp.
Ava madekona avudhi.
Okay,
I
sharp.
would never do anything.
Ai asori ndikuedera like ndikotohamba uri. Yeah.
Oh, Rachilumera, if you have anything rather than electromagnetism, you can bring, but if it is electromagnetism another time.
So you can do circuits. Can you do circuits?
Yeah, circuits I can do.
Let's go for circuits. Let's go.
Oh, electric circuits.
Yeah.
I actually love electric circuits
Why?
because I find them easy.
Yeah. So well.
They are pretty easy if you understand them. So here is electric circuit here. So now at electric circuit, it says that the circuit diagram below shows identical light bulbs X, Y, Z.
Please zoom in a bit. Zoom in.
Okay, thank you. Is it fine now?
Yeah, it's okay.
Okay, let me just see something. I wanna see the time. Okay, let me just do this. Okay. So now it says, you can read the information for us.
Circuit diagram below shows the identical light bulbs X, Y, and Z connected to a battery of negligible internal resistance.
Mm.
Two voltmeters, I almost said volunteers. Two voltmeters are switch S, and two ammeters are also connected in the circuit as shown.
Mm.
Switch S is open. How
Yes.
will the brightness of bulb X compare to bulb Y? Choose from X is brighter, X is dimmer, and X and Y are equally bright. Give reason for your answer.
Okay, let's check the information more closer. You see that a circuit diagram below shows three identical bulbs connected by the battery by negligible internal resistance. So the two voltmeters, a switch, and two ammeters are connected in this, and then they say switch S is open, and then they say that now how does the switch S is open? Okay, so it means this resistor is not working, this one. So because this bulb is not working because this switch is open, so it means current is only flowing here. How does the brightness of bulb X, so it means it's this one, compare with the brightness of a bulb Y here, and then say choose X is brighter, X is dimmer, or Y is there. Give a reason for your answer. What would you say there?
Me, I would say they are equally bright
Why?
because current it's flowing to both of them.
Okay, and yeah, but it's not a yes, it's fine, but the way to say it is just to say they have same resistance. If like they had different resistance, another one was gonna glow different than another because they are identical. You get that they're identical here. It's gonna be the same. And another thing that determines brightness is power. You know how to calculate power, ne?
Yeah, those formulas.
The greater the power, the greater the brightness.
Mm.
And then it says that switch S is now closed. Switch S is now closed. And then it says that which of the ammeters A1 or A2 will have a brighter reading. So is A1 or A2. So they say switch S is closed. So
It's closed.
which one will have a higher reading?
I think A2.
Why do you say that?
Wait, let me check where is A1. Oh yeah, A1. I didn't see A1. I thought it was V2. A1 will have the highest reading
Yes. What's the
because
reason?
current flows from positive to negative terminal. Zambori current flows through A1 first.
But they didn't say where does it flow to first. They say which one will have a greater value when you compare the amounts of the two. So the way to determine which one will have a greater value is that now if when current comes here, it's going to be divided.
Oh yes.
It's gonna be divided to here and here. So meaning that this one gets a divided current,
A
which is
smaller reading.
a smaller
Yeah.
reading. Yes, that's how. Use the relevant equation to show the readings on V1 are equals 2 times the reading of V2. So here's if your V1, here's your V2. Show calculations that this V2 is 2 times V1. What do they mean by that? They mean that show by calculation that the voltage on the V2 will be 2 times the voltage on V1. How do you show with calculations?
I don't know.
So the first thing that you must know is that now, when you think about it, you just first see that okay, here there's gonna be a total resistance, ne? There's gonna be a total resistance, and then here there's gonna also be a, for example, a a resistance based on parallel. So now you are going to compare. You are going to compare to say that now V, when it comes to here V1, it will be equals to IR. Remember that we don't have any values that we're using here. But when it comes to the V2 here, you must know that because current will be split into two here, it's gonna be split into two. Current is gonna be half. It's gonna be half. Let me write I like this so that you differentiate it away from one. IR. So the voltage across each embedded resistor here is gonna be a half of the current. You get me? Because it's gonna divide into two. And why is it dividing to half specifically? Why doesn't it divide to maybe 2 and 3? Why does it divide by half? Is because the resistors are identical. They have the same resistance.
Oh.
Yes. So that's why. So now if you come here and then you'll see that, okay, now if you check the voltage, V2, there's half. What does this thing represent? It represents the V2. Meaning what? Meaning the V2 reading is
It's half
it's half
V1.
V1. Yeah, this is gonna be V1. It is half V1. So that's how you solve it, to say that V2 is half V1. Or maybe another way that you were gonna do it, you were just gonna say, let's come to this one. If you come to for the example, they are looking for the voltmeter V equals to IR. And then you come to here, and then you say, okay, V, this one is for the first one. The second one, you are looking for, you are checking all the resistance here. You are checking all the resistance to say that now, you know that a voltage in parallel is the same.
Yes, I don't know that.
So now we are checking we want the voltage across all these the voltage across all these parallel combination here. We are looking for the V parallel. It means that now it will be the total current, because total current is gonna enter this. We are treating this as one resistor, as one big resistor. You get me?
Yes, I do.
Is it who's raising your hand? It's you, ne?
No, it's not.
Or we are the target.
Nṋe ndo to vhuya ngori ndi khou humbula thi songo downloada question papers dzo fana hedziḽa dze vha sendela Faith, but then ndi khou nyanga ya 2021.
Yenda sendela Faith ndi ya lini?
Ndi ya 2019.
Ndi ya 2019. Okay, let me you go to Stanmore Physics. Go to
Ndo dzhena, but then yo ḓala zwithu zwinzhi. Ndi khou nyanga i tshi vha package yo fana na heiḽa hafho yo khou mbudza FS April question paper in memo KZN. How do I download zwithu zwithu khathihi?
Press where there is where it is written study guides. There's study guides up there.
Let me go back because nda ndo na dzhena kha past question papers.
So now if you check the resistors, how do you add the resistors in parallel?
In parallel, we say one out of that specific resistor.
But if there are two, how do we add them?
If they're two.
If there are two, how do you add
one out of, okay, let's say, okay, one out of R1 plus one out of R2.
You don't know this equation?
No.
This one.
But then, oh yeah, I do know it. Yeah, I
Yes.
have seen it.
So now if there are two, you can add them like this, but it is the same thing as this, but they just manipulated it and you left with this there. So now you can come and put this formula here. It's still the same way of proving, but here we are treating all this as one resistor. That's why we are adding all this resistance. Ne? So the R times R. Remember that we are not rating R1 or R2. We are just rating R because they are identical. Zvikhoita ngapo Daki?
Wonderful, thank you.
Okay, no problem. And then Vp equals to I, and then it's gonna be R squared over 2R. Ne?
Mm.
And then it's gonna be Vp equals to I, and then this R is gonna cancel here, and then it's gonna be R divided by 2. You get me? And then it's gonna be V I equals to this is I multiplied by half R, and then it's gonna be half I over R because there's no multiplication order. We can,
Yeah.
and then you just come and say V equals to half V1. We are done. V this IR equals to V for V1. Just come and say that okay, the V in parallel is half, meaning that is half to V in series, meaning that V series is 2 times V in parallel. That's the two ways of doing it.
I say. Say.
Yes.
Hey, let me give you time to rest.
Hey, okay, no problem. You
But
also
then, thank you so much.
you also wanna rest, ne?
Yeah.
Okay, no problem. Yeah, we maybe next time we'll talk when there's still time.
Yeah.
Okay, yeah, no problem.
Thank you so much.
You're welcome. All the best with your exam, ne?
Thank you.
Sharp. Okay, bye everyone who managed to join. I'll see you next in the next live. You can leave in a comment if you have a question paper that you want us to do.